Hello, welcome back. Today we are going to be taking a look at the derivative when the base is not e. Now you might recall yesterday in our video we said to take the derivative of e to the x, we're just going to get e to the x back. There is a little bit more to this derivative. We're not ready to prove it just yet. We'll talk about that later on. But today we're going to take a look at what happens, how do we take the derivative when the base is not e. And to do this, let's review basic exponentials. If we have the exponential function a to the x equals b, if and only if the log base b of log base a of b equals x. This we talked about when we did logs the other day in exponentials. This is just our inverse property right there, that we can rewrite logs as an exponent and exponents as a log, where a is the base, because today it's all about that base. No trouble here. X is our power, and b is what the value is going to become. The one thing I want to share with you is this x right here. Notice the x there, right here, is the exponent, is the power of my exponential. In other words, this log base a of b, this is just the power on our exponential function right there. All right, might help us out later on. The next property we want to talk about is the change of base property. And this one we like a lot. In other words, if I have the log base a of b, I can write this as the natural log of b over the natural log of a. And you might recall from yesterday, we know this one. We talked about the derivative of natural log of b. The derivative of the natural log of x, we said the other day, was just 1 over x. So we're going to like this. We're going to use this in just a few moments. So let's see here. We want to write this as a logarithm right here. So if I want to write this as a log, all right, so let's take a look here. My base is 2, so I'm going to write this as log. The base here is 2, so the base of my log is 2, of 16, and that's going to equal my exponent. And that's what this is saying. This right here is my exponent. That the x right there is my exponent. I can just rewrite that. And let's talk about use properties, log properties to solve. We saw this the other day, or something similar to it. If I have x squared minus x equals log base 3 of 9, I can use my logs properties from Algebra 2 and Pre-Calc. You said we can write this as log base 3 of 3 squared. And by writing the 9 as 3 squared instead, because I want to get that same base, I want those bases to be the same. And once they're the same, they just cancel out. And what we're left with is x squared minus x equals just a 2. And then I can solve this one. X squared minus x minus 2 equals 0. Factor like an actor, driving a tractor. We're going to factor that. X minus 2, x plus 1. And we get our two answers. 2 and x equals negative 1. And there we go. There's our answer right here. You go and try one. What's the common base between 2 and 64? Well, it's actually base 2. So I can write this as log base 2, 2. And I think 64 is 2 to the 8th. Let me check that. 2, 4, 8, 16, 32, 64. I was way off at 6. So that's 2 to the 6. Right here. Those will cancel because they're the same base. And I get 3x plus 5 equals 6. I can solve that. Hopefully in one step. Bring over the 5, divide by 3, and we get 1/3 right there. All right, let's have some real fun with some logs. Okay, here we go. Same type of problem. Logs and exponents, they're solved the same way. We just want to make sure we can get the bases the same. And here I have 2 to the x plus 3. Well, this 4, I want to write it in terms of this base. I can write this as 2 squared to the 2x plus 1, minus 1, excuse me. And again, if the bases are the same, they can just kind of go away. And what I'm left with is this x plus 3. Distribute here. We're going to get 4x minus 2, and I can solve it. 3x equals 5, x equals 5/3. And there's our answer. Look at this. All right, for number 4, we're going to use that little trick we talked about the other day. Exponentiation is just a cool word to say. Exponentiation. And what I'm going to do here, remember, this is where we're going to use the base to get rid of the log. And my base here is 3, so I'm going to make both sides an exponent. These bases are the same, they cancel, and we're left with x minus 2 equals 3 squared, which is just 9, so I can solve it. I get 11. And there we go. That's just basic log stuff. You can review your log properties here. Remember our log properties. So if I am adding two logs with the same base, I can multiply them together. And again, that comes from our product rule for exponent rules. Logs and exponents are the same. They're just inverses. So, and my inverse, if I'm multiplying the same base, I can add the exponent. I can go forward and backward if I wanted to. By the way, we're going to use this skill quite a bit backwards later on this year, toward the end of the year. Let's see here. Log base b minus log base b. Well, if I'm subtracting, I can divide the exponent, the numbers there, x and y. Likewise, where do we get it from? It comes from our quotient rule with exponents. If I'm dividing, I can subtract the bases. I can subtract the powers, excuse me. And then we have the exponential rule, right? If we have a power a to the p, I can drop my power. And again, it comes from my power rule from exponents. If I have an exponent to another power, I can multiply those powers together. So take a look at those. We will be using these today. Don't forget, we did this with natural log too. We like these because they help us to expand our properties there. All right, go on to the next video, and we'll take a look at the derivative of these bases where they're not E. I'll see you then.